What if a massive asteroid hit Earth tomorrow? It's a terrifying thought, one that feels like it belongs in a Hollywood blockbuster. But the threat is very real. Our solar system isn't an empty void. It's a cosmic shooting gallery, and Earth is constantly in the crosshairs. But what would actually happen if our planet took a direct hit from one of these celestial behemoths? Let's journey through this cataclysmic scenario, from the initial impact to the long, dark aftermath. To understand the threat, we first need to understand what we're up against. Asteroids are rocky, airless remnants left over from the early formation of our solar system about 4.6 billion years ago. They orbit the Sun, and the vast majority of them are found in the main asteroid belt, a region of space between Mars and Jupiter. But their orbits aren't always stable. Gravitational nudges from planets, especially the giant Jupiter, can send these space rocks hurtling into the inner solar system, placing them on a potential collision course with Earth. Their sizes vary dramatically. You have countless small ones, the size of pebbles or boulders, that burn up harmlessly in our atmosphere every day, creating the beautiful streaks we call meteors. Then there are the larger ones, a few hundred feet across, which can cause significant regional damage. But the ones we truly fear are the planet killers. These are asteroids measuring a kilometer or more in diameter. An impact from one of these wouldn't just be a bad day, it would be an extinction-level event, a catastrophe on a planetary scale. Now, let's talk about the energy. When you think of a big explosion, you probably picture a nuclear bomb. The bomb dropped on Hiroshima released energy equivalent to about 15,000 holodot of TNT. Now imagine an asteroid, a kilometer wide, screaming through space at tens of thousands of miles per hour. The kinetic energy it carries is almost incomprehensible. Upon impact, all of that energy is released in a fraction of a second. We're not talking about thousands of tons of TNT, we're talking about millions of megatons. The explosion would be thousands of times more powerful than the entire world's nuclear arsenal being detonated all at once. It would create a crater over 100 kilometers wide and several kilometers deep, instantly vaporizing everything within a vast radius. The sheer force of this impact would be enough to fundamentally alter the geology of the planet. The moment of impact is just the beginning of the horror. The energy released would create a colossal fireball, incinerating everything for hundreds of kilometers in every direction. Simultaneously, a shockwave of unimaginable power would race outwards from ground zero at supersonic speeds. This isn't just a strong wind, it's a wall of compressed air that would flatten forests, pulverize cities, and obliterate any structure in its path. If the asteroid were to strike an ocean, the devastation would be even more widespread. The impact would displace a staggering volume of water, generating a mega tsunami. This wouldn't be a single wave, but a series of waves, some reaching kilometers in height, traveling across entire oceans at the speed of a jetliner. They would inundate coastlines thousands of kilometers away, sweeping inland for unimaginable distances and erasing entire coastal civilizations from the map. But the most devastating and long-lasting effect wouldn't come from the blast or the waves. It would come from what the impact throws into the sky. The explosion would eject trillions of tons of pulverized rock, dust, and debris high into the atmosphere, far above the clouds. This material, along with soot from the widespread fires ignited by the impact, would spread rapidly, carried by stratospheric winds. Within days or weeks, a thick, dark shroud would envelop the entire planet, blocking out the light of the sun. Earth would be plunged into a perpetual twilight, a deep, gloomy darkness that could last for months or even years. The sky would turn from blue to a permanent, oppressive black. The sun, our source of life and warmth, would become a faint, barely visible ghost. This brings us to the final, chilling stage, the impact winter. With the sun's light blocked, global temperatures would plummet dramatically. The planet would quickly fall into a deep freeze. Average temperatures on land could drop below freezing, even at the equator. This rapid and drastic climate shift would trigger the collapse of ecosystems worldwide. Photosynthesis, the foundation of nearly all life on Earth, would grind to a halt. Plants would wither and die in the cold and dark. With no plants to eat, herbivores would starve. And with no herbivores, carnivores would soon follow. The food chain would collapse from the bottom up. The oceans, which absorb much of the planet's heat, would cool more slowly, but the lack of sunlight would kill off the phytoplankton, the microscopic plants that form the base of the marine food web. The seas would become barren graveyards for any life that survived the initial blast, the tsunamis. And the fires, a long, dark, and frozen struggle for existence would begin. It would be a fight for survival on a dead and desolate world. Our existence on this small blue marble is more fragile than we often realize. We live in a cosmic neighborhood filled with ancient debris, and the laws of physics are indifferent to our survival. This scenario isn't science fiction. It's a reminder of the powerful and often violent forces that shape our universe. While organizations like NASA are working tirelessly to track these potential threats, the story of an asteroid impact serves as a humbling lesson. Our planet exists in a dangerous universe, and its future is never guaranteed. Thanks for watching. If you found this journey into the cosmos thought-provoking, please consider liking this video and subscribing for more explorations of science and space.